Hello, in this video we're going to be discussing graphing f of x is ax squared plus c. Our essential question is how does the value of c affect the graph of f of x equals ax squared plus c. In our last video we talked about how this value of a affects your graph. As the value of a gets larger, your graph will become more narrow. Or I should say as the absolute value becomes larger, it will become more narrow. As the absolute value becomes smaller, your graph will widen out. If a is negative, we saw that your graph will go from facing upwards to facing downwards. So now what we are looking at is just this value of c and what effect that is going to have on our graph. So sketch the graph of the function in the same coordinate plane. What do we notice? I'm going to graph f of x is equal to x squared in black, and then I will graph my new function g of x in red so that we can easily tell the difference between the two. So creating a table, I'm going to go ahead and start at -3 and then -2, -1, 0, 1, 2. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and I'll also do 3, 3 squared is 9. Plotting these points, my graph is going to take the shape of a parabola because this is a quadratic expression. Actually, these points should be at 9. So -3, 9. So my graph should look something like this. It is a U-shaped graph that is based out of the origin, or this point, this turnaround point, the vertex is what we call it, is at the origin. So now for g of x, it equals x squared, so all the same numbers I had before. But now we are going to add 2 to all of them. So I'm going to have my x and my y. When I input a -3, the x squared, just like before, is 9. But now we're adding 2 to that to get 11. For -2, my x squared is going to be 4, just like it was before, except now we're adding 2 to get 6. -1 used to give me a 1, but now I'm adding 2 to that to get a 3. 0 used to give me 0, but now I get 2. 1, now I get 3. 2, now I get 6. And 3, now I get 11. So -3, 11, I've got a point here. -2, 6, I've got a point here. -1, 3 here. 0, 2 is here. 1, 3, 2, 6, and 3, 11. So my graph looks something like this. Now, of course, my graph is far from perfect, but what happened is that all of these y values from the black graph were simply moved up 2 units. So instead of being at 0, now I'm at 2. This y value is 1. Now I'm up 2, and my y value is at 3. Here my y value is at 4, but we shifted it up 2 to get 6. Here it's at 9, but we moved it up 2 to get 11. And same thing on the right. This y value of 1 moved to a y value of 3. This y value of 4 moved up to a y value of 6. This y value of 9 moved up to a y value of 11. So that plus 2 just simply took all of our old y values and moved them up 2 to get our new y values. My x values didn't change at all, only those y values moving my entire graph up 2 units. So now we're going to look at a graph very similar to the last one, except we have a coefficient of 2 on our f of x and g of x functions. So we should know that our graph is going to be a little bit more narrow than my original x squared graph. I'm still going to use, since we're multiplying everything by 2, I'm just going to do -2, -1, 0, 1, 2. -2 squared is +4, and then I multiply +4 times 2 to get 8. -1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is still 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. So I have a negative 2, 8, negative 1, 2, 0, 0, 1, 2, 2, 8. We're going to move on to graph g of x. So g of x is 2x squared minus 2, and I'm going to make a table. I'd like for you to take a moment to predict what you think is going to happen to my f of x graph when I move to my g of x graph and subtract 2 from my f of x. Let's take a moment to maybe jot an idea down, and then we'll see if your prediction is correct. For my x values, I'm going to use the same values as before. I have my f of x function, 2x squared, but I'm taking 2 away from that value. So when I put in a negative 2, my 2x squared is 8, but then I subtract 2 from that and get 6. When I put in a negative 1 to my 2x squared, I get 2. So this 2x squared is 2, but then I take away 2 and get 0. When I put in a 0 to my f of x graph, I get 0, so that's my 2x squared, but then I take away 2 and I get negative 2. Inputting a 1, I get a 2 for my 2x squared portion, then I subtract 2 to get a negative 1. Or sorry, I get a 0. When I put in 2, I get 8 for 2x squared, but then I subtract 2 and I get 6. So plotting all these points, negative 2, 6, negative 1, 0, 0, negative 2, 1, 0, and 2, 6. So my graph is going to look more or less, let me try that again, like this. So what we can see is that if we compare all of the y values, all of our y values simply got shifted down 2 units. Down 2 from 8 to 6, down 2 from 2 to 0, down 2 from 0 to negative 2, and same thing on that right-hand side. So the graph of our g of x function is simply f of x. It's the same shape, but f of x got shifted down 2 units. So that minus 2 simply took our whole f of x graph, picked it up, and moved it down 2 and dropped it. Okay, so we've got a very similar question here. We are going to graph g of x and compare it to the graph of f of x. I'd like for you to go ahead and pause the video and try completing this one on your own. So first I have graphed my f of x function, that's f of x equals x squared, and now I'll graph my g of x function. So the g of x function is in red, and that's x squared minus 2. So it looks like all that happened was we took my black graph, we picked it up, and we dropped it 2 units down. So g of x is f of x, but f of x got shifted down 2. That is the only difference between these graphs. So this minus 2 took my whole graph and shifted it down 2 units. Go ahead and take a moment to pause the video and practice graphing these two on your own. Make sure that you take the step of comparing the graph in 1 and 2 to the graph of the parent function, f of x equals x squared. So in number 1, it looks like we took my f of x function, my x squared, and then we just shifted it down 5 units. To get that red graph that I've graphed below. And in number 2, we took f of x, so that's my x squared, and then we shifted it up 3 units because we are adding 3. And that gets us to our blue graph here. Okay, so example 2, We are going to graph one more, but this one has a coefficient on x squared, and we are also adding 1. So we know that it's going to be more narrow, and we know that it's going to be shifted up 1. So this is what we can expect from our graph, but I'm still going to go ahead and make a table to help me obtain the most accurate graph possible. So I've got x and y, and this will be for g of x. But first, since we are kind of doing a new type of transformation, I'm going to graph my f of x as well. So f of x, I'm going to start with a -3, -2, -1, 0, 1, 2, 3, and we're just squaring all those values to get 9, 4, that looks like a 9, 9, 4, 1, 0, 1, 4, 9. So I've got 0, 0. If I start here in the middle of my graph, the pattern to get to the next point is simply to go to the left one and up one. So left one and up one. To get to the next point on the left, from my middle, from this vertex point, I'm going to go left 2, up 4. So 1, 2, 3, 4. And that gets me to this point here. So this was left 1, up 1. This was left 2, up 4, and then my next point on the left, I need to go left 3 and up 9. So left 1, 2, 3 and up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are all from that middle point or that vertex or turnaround point. On the right side, I go right 1, up 1. So right 1, up 1. Then I'm going to go right 2, and then I go up to 4 for my y value of 4. So right 2, up 4, and my last point, I'm going right 3, and I go up to 9. So right 3, up 2, 4, 6, 8, and 9. And that gets me to the graph of my f of x function. Now this is going to be your home base pattern always. We're always going to start with this pattern. We then multiply our ups by whatever your coefficient is, and that will cause your graph to become more narrow. So in this case, I'm going to take all of those ups and multiply them by 4 to get to my graph of g of x. Now to show you that, I am going to go through a chart here. And we'll compare the values in just a moment. So I'm going to go ahead and have -3, -2, -1, 0, 1, 2. So x squared, -3 squared is 9, times 4 is 36, and plus 1 gives me 37. -2 squared is 4, times 4 is 16, plus 1 is 17. -1 squared is 1, times 4 is 4, plus 1 is 5. 0 squared is 0, times 4 is 0, plus 1 is 1. 1 squared is 1, times 4 is 4, plus 1 is 5. 2 squared is 4, times 4 is 16, plus 1 is 17. And then, since this is symmetrical, I would have 337. Now, this is not going to fit on my graph, but I can go ahead and at least graph these 3 points. So 0, 1, -1 and 5, +1 and 5, -217 would be way up here, and +217 would be way up here. So my graph is going to look super narrow and something like this. Now what I want you to see is that my pattern used to be left 1, up 1. But now if I start at the middle, if I start at that vertex, I'm going left 1, up 4. Just like I told you, we're going to take that up and multiply it by 4. Same thing for my right 1, up 1. We used to be going right 1, up 1, but now I start at that vertex and I go right 1, up 4. This is something that we're going to be exploring as we go on in our practice of graphing parabolas. Go ahead and take a moment to practice these last couple on your own. You can pause the video one more time to check your graphs and your transformations. Thanks so much for watching.